All right. So here's an example of implicit differentiation. Again, you had to find the slope of a tangent line. So the graph of a given equation, x squared plus xy minus y cubed equals 7 at the point 3, comma 2. So in short, what implicit differentiation requires or consists of is differentiating both sides of this equation by a single variable. In particular, the variable that we're going to use here is x, right? So the first thing I like to do is write out the equation in the middle, x squared plus xy minus y cubed equals 7. I put usually parentheses around it, and on the outside, I say we're taking the derivative with respect to x, d dx. Okay, so if the variables agree, right? If your variable of differentiation agrees with your term, then you take your derivative like how you normally would. Now, if the variables don't agree, you're going to essentially have to use a chain rule. All right. But it's an intuitive chain rule. You'll see. First of all, what is the derivative of x squared? It's going to be 2x. Derivative of x squared is 2x. Now, how will I find the derivative of xy? No. Remember, this says x times y. You have to apply a product rule. So here you apply a product rule. So by your product rule, you need to define your f and g. So let f be equal to x and let g be equal to y. Now, remember, you're taking both of these derivatives with respect to x. So what is the derivative of x? 1. Now, under normal circumstances, what is the derivative of y? Well, it's 1 if you were to take the derivative with respect to y. But since we're taking the derivative with respect to x, we say 1 times dy dx, or y prime. Right? So it's 1 times dy dx. I prefer to use dy dx rather than y prime because sometimes for beginners, y prime could look like y to the first power and you can get it confused and you can totally botch the problem. All right, so our g prime is just simply dy dx. Okay, so by our product rule, you take f times g prime, g times f prime. So we're going to get 2x plus x dy dx. Then g times f prime, that will be y times 1, which is just simply y. And now you apply another, intuitively, a chain rule for negative y cubed. Under normal circumstances, what is the derivative of negative y cubed? It will be a 3, yes, so it's negative 3y squared. There you go. So you get negative 3y squared. Oops, sorry, I already had the negative there. So it's negative 3y squared. But since we're taking the derivative with respect to x, what do I attach? You have to attach your dy dx. Very good. And what is the derivative of 7? 0. Okay. We just did the whole calculus of this problem, was finding the derivative. Now what you're going to do here is rewrite this in terms of dy dx. So how do I rewrite this in terms of dy dx? First, the terms that do not have a dy dx, you have to move it to the other side of the equation. So what terms do not have a dy dx? The y, the positive y, and the positive 2x. So I can do this in one step. I can subtract 2x and subtract y on both sides. So the 2x and y's will cancel. This will give you x dy dx minus 3y squared dy dx is equal to negative 2x minus y. Now look at that left-hand side of the equation. What does the left-hand side of the equation have in common? Yeah, you have a dy dx in common. So the dy dx, oh, my bad. The dy dx that you have in common here, you can essentially factor it out. So if I factor out this dy dx, then inside the parentheses should be x minus 3y squared On the right-hand side, we have the negative 2xy. To get dy dx ultimately by itself, because that's what we want, you divide by x minus 3y squared. So x minus 3y squares cancel. This will give us dy dx is equal to negative 2x minus y over x minus 3y squared. Now that's our derivative. But what we wanted to do was to find the slope of this tangent line evaluated or at the point 3, 2. So what we have to do now is just take that point and plug it into the derivative. Okay, so M10 equals dy dx at, or evaluated at 3, 2. So wherever I see an x, I replace it with a 3. Wherever I see a 2, replace it with a y. You're going to get negative 2 times 3 minus 2 over 3 minus 3 times 2 squared. So what's negative 2 times 3? That's negative 6. Negative 6 minus 2 is negative 8. In the denominator, you apply PEMDAS, so you square 2, so that's 4. Then multiply negative 3, which is negative 12. Right, so this number here is negative 12. So if you have 3 minus 12, what's 3 minus 12? Positive or negative? Negative. So you have negative 8 over negative 9. The negatives will cancel, and you get 8 over 9 as a solution. And that would be it to our applying implicit differentiation, where more importantly, you were getting the slope of your tangent line.